My name is Meha, and I'm an assistant professor in the School for Environment and Sustainability at Michigan. And I just thought I'd start off and tell you a little bit about how I became really interested in sustainable food systems and how I got started on this research path. So I think as early as undergrad, I knew that I was really interested in environmental work and trying to understand how we can conserve natural resources and protect the environment in the face of climate change. So what I did is, like you guys, as an undergrad, I got involved in some research that was going on with different professors at the university that I was attending. And through that, that just really helped me figure out what I was really excited about, what sort of research questions, I just felt most passionate about. And then I decided to go do a PhD. So I did a PhD a few years ago. So I graduated in 2014 from that program. And I knew that I was really interested in agriculture in particular, just because I think this is one of the sectors that's going to be most impacted by climate change. And it's also a sector that's incredibly important for people. So some studies estimate that climate change is going to reduce yields by up to 20% in some regions for some crops. So I was really interested in figuring out ways that we could reduce some of this damage and make sure that we can still produce food moving forward. So yeah, after I did my PhD, I then did a postdoc for 2 years in California, and then I decided to move back to the Midwest. I'm originally from South Bend, Indiana, a few hours away from Michigan, so I decided to move back to Michigan for this position here. So I'd be happy to talk a little bit more about my path during the question and answer session if you guys are interested, but for now I'll just go into the research that we're doing in my lab. So today I'm going to present some work. It's a little bit different than the paper I had you read, but it's broadly under the same theme. And right now we have a grant that's being funded by NASA. And the goal of the project is to try to understand how is environmental change, including climate change, affecting agricultural production specifically in India? And is there anything farmers can do to change their management practices or adapt to reduce negative impacts? The reason I'm focusing on India is because it's one of the main agricultural producing countries globally. So it's actually the second largest producer of both rice and wheat across the world. And it's also home to over 500 million smallholder farmers. So unlike the US, where if you look at US population and you look at the percent of people who are farmers, it's about 1%. In India, 50% of the population actually practices farming as a main livelihood. So agriculture is not only really important from a matter of food production and food security, but it's also really important as a matter of livelihoods and helping these rural families earn enough money and income. So if you go to the next slide, I just included a picture of one of the farmers that we worked with in northern India, plowing his fields using ox carts. So in India, unlike here in the US, it's not very mechanized and it's not very large scale. So in India, most of the farmers are what are called small scale producers. So what that means is on average, farmers have about 2 hectares or less of land. So I would say you could think of this as someone having, I'm trying to think a good comparison, maybe like 1/10 of a football field of land that they're trying to grow food on. And the food that they grow on this land is what's providing most of their livelihood. So they're not farmers who have really, really large fields. They don't have tractors oftentimes to, help with doing work. It's often much more manual and localized small-scale production. I just included a graph showing where India's GDP primarily comes from, and agriculture makes up about 20% of the country's GDP. So you can see that agriculture is really important for India from a food security perspective, from a local livelihoods perspective for rural communities, and then also from this perspective of the national economy. So that's why I decided to focus on India. So thinking about what are the sorts of changes that are happening in this country, We know that temperatures are warming. This is something that's happening to almost every agricultural system across the globe. But in India in particular, we're seeing rapid warming temperatures. And this is in particular really problematic for the crop wheat. So if you guys remember, I said that India is one of the largest producers of wheat globally. And wheat has been shown to be one crop that's most negatively impacted by warming temperatures. And that's because there's this specific stage of wheat where the grains start to grow on the crop. And if it's really hot during that time period, you can see really sharp reductions in yield. So some studies have estimated that in India, that wheat will decrease by about 20%. Wheat yields will decrease by about 20% over the next 50 years just due to warming temperatures. At the same time, not only are temperatures warming, but you're also having changes in rainfall patterns. So in India, the main form of rainfall that happens is something called the monsoon. So for those of you who have never experienced a monsoon before, it's really, really exciting. Basically, most of the rainfall for a given year falls within a few month period. And those few months, so in India, it's usually June through September, you have really intense rainfall events. But what a lot of researchers have shown is that with climate change, what's starting to happen is that not only is rainfall becoming much more intense, it's also becoming much more spaced out. So basically what's happening is, maybe 50 years ago, we had a little bit of rainfall every single day or every other day throughout the growing season, throughout, June through September. But now what's happening is you might have a really, really heavy rainfall event one day, and then you won't see any rainfall for a week or 2 weeks. And then all of a sudden you'll have a really, really heavy rainfall event again. So the reason this is problematic is if you think about a crop, I don't know if you guys garden or if you grow plants at all, you know that your plants really do best if you're just giving them a little bit of water sort of slowly throughout time. And you could imagine that if the rainfall patterns are changing, where instead you're getting these big extreme events, that could be problematic because it could lead to flooding of your field. It could lead to periods where the crop is really, really dry. So not only are farmers dealing with warming temperatures, they're also dealing with these changing rainfall patterns. And at the same time, farmers are also being faced with another shock, which is reductions in access to irrigation. So a lot of the irrigation that farmers use in India comes from groundwater. So these are basically wells that farmers have dug and they're pulling water from deep depths underground. And the benefit of this groundwater is that it's a really reliable source of irrigation. But because India has been using their groundwater really extensively, India is actually the largest consumer of groundwater worldwide. What's starting to happen is that 50% of the wells are starting to dry up and basically water tables are falling. So what people have estimated is that because of these falling water tables, farmers aren't always going to have access to groundwater irrigation. Say over the next 20 or 30 years, these resources might dry up. My main research question under this grant is I want to understand how are farmers adapting to these multiple environmental changes? Not only are they seeing warming temperatures, they're seeing changing rainfall patterns, and they're also experiencing this potential loss in groundwater. So I want to know, are farmers changing their cropping strategies based on this? The second question is, I want to understand how effective are these strategies in reducing some negative impacts? So let me just give you an example of a potential adaptation strategy. So for example, if farmers are facing really warm temperatures, and wheat is one crop that's really negatively impacted by warm temperatures, maybe farmers might adapt by switching to a different crop like maize that isn't as negatively, or corn that isn't as negatively impacted by warming temperatures. So basically, I'm interested in seeing how farmers are changing their practices in order to reduce the negative effects of these shocks. The third question that I'm really interested in understanding is, as you guys saw from the article that you read in Gujarat, is not every farmer responds in the same way. So even though they might have the same rainfall shock, they might have the same temperature shock, but different farmers will make different decisions. And I'm really interested in understanding what are the factors that explain why certain farmers adapt while other farmers don't, and are there specific constraints that are stopping farmers from being able to adapt? And if so, is there anything we can do to reduce those constraints and enhance adaptation? And then finally, you might be wondering, why is NASA funding this sort of research? And the reason is because a lot of our work, not only do we rely on household surveys like the paper you read in Gujarat, we also rely on using satellite data to actually map a lot of these factors that I talked about that we can view at really, really large scales. And as I'm sure you guys have heard of before, basically NASA and other space agencies, part of their budget and part of their work that they do is they actually put up satellites that take pictures of the Earth on a daily or weekly basis. And then researchers like me, we're called remote sensing scientists. We basically come up with algorithms or methods where we can download those images and actually change them or transform them into data that we actually care about. So I'll show a few examples of how we do this in our work moving forward. I just wanted to highlight what the benefits were of using satellite data. You might think, well, why would you use satellite data? It seems like you have to do a lot of work to actually turn the pictures that the satellites take into data that you can actually use. And the reason is because before people started using satellite data to answer these questions, they would normally use what are called census statistics. So basically, a lot of governments across the world collect census data. You know, we have population census that I'm sure many of you are familiar with, but in addition, we also have agricultural census statistics. So in India, for example, the Indian government every year conducts a census where they record what crops are being grown in every district in India, what's the yield of that crop. So a lot of studies will use these data to try to measure adaptation and how farmers are changing their decision making. So what I mean by adaptation is what these studies will do is they might project, well, how much yield are we expected to lose if temperatures warm by, say, 1 degree? And that's what's highlighted here in this one gray bar. What loss you might actually have under that second bar. So say without any adaptation or without any change in practice, you might assume that based on your models, you might think that 1 degree warming of temperature would result in a 20% reduction in yield. But in reality, if farmers can change their practices, then they might be able to make that yield loss only 10% and actually reduce the negative impact of warming temperature. And these sorts of analyses, so basically looking at how much were we able to reduce the negative impact of, say, warming temperatures, that's something that you can do using these sorts of census data. I say that the benefits of using these sorts of census data are that they allow you to actually measure adaptation. You can say, okay, farmers were able to reduce their loss from 20% to 10%. And it also allows you to ask these questions at really large scales because these census data are available across the whole country. So you don't have to just focus on a single area. You can actually look at all of India and see how people are changing and adapting across all of India. But the downside of this work is that you don't actually know anything about the decisions farmers are making because you're not actually talking to any given farmer. You don't really see what's going on behind the scenes. So the second type of approach that many people use is people will go into the field and do surveys with farmers. So this is what I did in that study in Gujarat, and this is me surveying a community in northern India. And we can do household surveys with farmers and ask them how they've adapted. The benefit of this approach is you can actually understand the decisions farmers made. So they might say, I changed the crop type I planted, I changed the date that I planted the crop. But the downside of this work is you can't really do it at very large scales because it takes a lot of effort to actually go into the field and survey people. What my work does is I take a mixed methods approach. And what that means is I use multiple different methods and I combine them together. And specifically what I do is I'll do household surveys like I have talked about and like you guys read about, but then I also use satellite data. And the benefit of satellite data is it allows me to measure these variables that we get from, say, the census data set, but at really fine scales. So these satellites will often take pictures of the Earth where we can basically see up to a 5-meter resolution or 30-meter resolution. And that means that instead of getting, say, one yield value for one county in the US, you actually get a yield value for every single individual farm within a given county. So it just provides you much higher resolution data. All right, so I'm just going to skip forward. I was going to present one research project that, well, I'm going to present 2 research projects, but first I'll talk about one of them. So the slide should show that temperatures are warming. So basically what I'm trying to understand in this project is I want to see what are some ways that farmers might be able to adapt to reduce the negative effects of warming temperatures. In order to do this work, I first created a satellite data product, and this was mapping wheat yields across all of northern India. So this region that's highlighted in yellow to blue, this is an area called the Indo-Gangetic Plains in northern India, and it's the main rice and wheat producing region in India. So I would say it's the equivalent to the Midwest in the US. And what I wanted to do was I wanted to map yields across this whole study area. And by using satellite data, I was actually able to map wheat yields at a 30-meter resolution. So what that means is for every 30 meters across this whole study area, which is really, really big, I was able to say what was the wheat yield at this given point at this given time. And I won't get into the details of how I use this, but how I created this, but I would be happy to answer those sorts of more technical questions during the Q&A if you'd like. And then what I did was I wanted to understand, okay, so in some areas you actually see really high yields. So for example, in the western part of that region, you see that a lot of the yields are really yellow. And that means the yields are really, really high, about 5 tons per hectare. And then if you go all the way to the east, you see that the yields are blue color, and that means the yields are very, very low. So they're only about 2 tons per hectare. And what I wanted to do was I wanted to understand, why are some fields really high yielding? Why are some fields really low yielding? And if we understand what are the factors that explain this difference, can that give us an idea of a potential adaptation strategy that farmers could take to increase their yields? So in order to do this, what I did was, don't worry about these models per se, I'll walk you through them right now. But what we did was we ran what's called a random forest analysis. And this is a machine learning approach where basically what I did was I had wheat yield as the dependent variable. And then I had all of these variables you see on these plots. So sowing date, temperature, elevation, soil type, canals, access to irrigation. I had all of these as variables that went into the model. And then I wanted to see which were the variables that most explained why some fields were low yielding and some fields were high yielding. And the way that you can interpret this graph is the variables that show up at the top of the list and also have their black dots most to the right. Those are the most important factors. So those are the ones that are explaining most of the variation in low and high yields. And interestingly, what we see is that temperature is typically one of the top 3 variables. So these 4 different plots represent the 4 different states that I did the study in: Punjab, Haryana, Uttar Pradesh, and Bihar. And what you can see is that temperature is one of the top 3 variables across all of these states. And that isn't that surprising because, like I said previously, we know that wheat is really negatively impacted by warming temperatures. The thing that was really interesting was that we see that sowing date is often the most important or the second most important variable. So what this was showing us was that this management factor, so basically when farmers decided to plant their wheat, had just as big of an impact in explaining what yields farmers got as this temperature variable. And we looked into this more, And basically what happens is that if farmers can plant their wheat early, then, so in India, wheat is a winter crop. It's usually planted in November and it's harvested in April. And remember I said wheat is one crop that's most negatively impacted by warming temperatures. This is because there's one period of wheat growth called grain filling, which is basically the crop has grown and the grains are starting to come into the wheat. And if you have warm temperatures during that specific time period called grain filling, you get really, really big losses in yield. But if you have warm temperatures at other parts of the wheat growth, it's really not that big of a deal. So in India, this period of grain filling usually happens around March. And that's also the time when temperatures are really, really warm. So basically, the temperatures in the winter stay cool until about February, and then the temperatures start getting pretty hot in March and April. So what we found was that if farmers can plant their wheat earlier, then you can actually have this important grain filling period happen in February when the temperatures are still cold. And then that reduces the negative effect of warm temperatures, because by the time March rolls around and it gets really hot, your wheat crop is already grown and it's not negatively impacted. So we've done a lot of work around this. I just showed one project, but we actually have 5 or 6 different projects that are looking at this question. And broadly, what we found is that farmers know that it's good for them to plant wheat early, but they're not always able to. And right now, our project is doing a lot of interviews with farmers. So we're interviewing 3,000 farmers across the same area, the Indo-Gangetic Plains, and we're trying to understand what are the main barriers to why they can't sow wheat early. So people know that they should be sowing earlier, but why aren't they able to? And that's what we're working on now. I don't have results on that yet, but hopefully we'll get some really interesting results from our survey. All right. Now I'm just going to very quickly for 5 minutes talk about a second project that we did in the lab. This paper was trying to understand how farmers might be adapting or responding to falling groundwater tables. So groundwater, as I said, India is the largest consumer of groundwater worldwide. It's a very important source of irrigation for farmers in India. It provides about 60% of India's irrigation, but over 50% of India's wells are losing water and are depleting. So what I wanted to understand was, how is this groundwater depletion going to affect agricultural production? If we lose all of this depleting groundwater, are we going to see really big negative impacts on production? And then the second thing I wanted to know was, are there any potential adaptation strategies to reduce these negative effects? The one thing the Indian government is doing is they're actually promoting canals as a different type of irrigation source in these areas where groundwater tables are falling. So basically the government's putting in a lot of money to build canals that can store water during the rainy monsoon season. And they hope that by doing this, farmers can then use that canal water to irrigate their fields, even if groundwater tables have fallen and they can't get access to groundwater. So what I wanted to do is I wanted to see, is this actually an effective policy? If you can get farmers to switch to canal irrigation, will that reduce the negative impacts of groundwater depletion? So to date, it's been really hard to do this work because there isn't really good quality data at high spatial resolutions or fine spatial resolutions on crop production. What my group did is we actually created maps of cropped area across all of India at a resolution of 1 by 1 kilometer. So here's a map just showing our cropped area product across all of India. Green shows areas that have a lot of agriculture. White are areas where agriculture isn't being grown. And you can see once again this area, the IGP in the north that I showed in the previous study, that's really the area that's popping out as the main agricultural region. So what I wanted to do is I wanted to compare how effective are groundwater sources to canal sources, because the government keeps saying, oh, it's not that big of a deal if we lose access to groundwater because we'll just switch all farmers over to canals. What I did was I did a regression analysis where I looked at, as my dependent variable, I have the amount of crop production, And as my independent variable, I have the type of irrigation. So I compared deep wells, I compared dug wells, which are really shallow wells that are close to the surface of the earth. And then I also compared it with canal irrigation. And what this plot is showing is it's showing the regression coefficients that you get after running the analysis. And basically the main take-home point of this is that I found that canal irrigation results in less crop production. So if you have groundwater irrigation versus canal irrigation, you'll have 50% less crop production if you rely on canals. We also found that canal irrigated villages, the crops were much more sensitive to rainfall. So if you have a really dry year, for example, you'll have really low production in canal irrigated areas. So basically what these results told me was that this government policy that the government is investing a lot of money in actually isn't going to be that beneficial. So we did some scenario analyses, and we found that without any adaptation measures, groundwater depletion in India will lead to a 20% loss in crop production across the country. And if you are able to bring in canals as an adaptation strategy, that loss will drop to 10%. But you're still having a big loss in production. You're still going to have a 10% loss. So what we say in this paper is that you can't just rely on this one top-down policy where you're going to try to get all farmers to switch to canal irrigation. We really need to start to think of other additional strategies. So for example, maybe we need to incentivize farmers to start planting crops that don't require as much water. Or maybe we need to incentivize farmers to use irrigation methods like sprinklers or drip irrigation that don't use as much water as their current practices. I just wanted to highlight that all the work that I presented today is in collaboration with a lot of great researchers across the world and also in my lab. So on this specific grant are the people that I mentioned here at the top. In the middle are students in my lab who are helping to work on these projects. And then on the bottom are researchers who helped me develop that map of cropped area across all of northern India.